the comparison fails before it begins. You are standing on Earth, trying to place the largest star ever discovered somewhere in the sky above you, but it does not stay there. It expands until distance stops existing, until the ground beneath you and the orbit around you are both pulled inside its boundary. There is no outside left to compare from. What was once a distant point of light becomes an environment, a surface that swallows the scale of planets without resistance. Not because it is violently expanding, but because it was always operating at a size your perspective could not hold. By the time this ends, the comparison you came for will no longer exist. The mistake is not that the star is larger than Earth. The mistake is believing they can be placed side by side at all. What you imagined as a comparison depends on distance, on separation, on the idea that two objects can share the same frame. But the moment one of them becomes large enough, that frame collapses. The space you need to measure disappears inside the thing you are trying to measure. This is not a difference in size, it is a failure of scale itself. Because what you are about to see is not simply a larger star. It is a structure so extended that familiar boundaries, surface, edge, and outside, begin to lose their meaning. And once those boundaries disappear, Earth is no longer something you compare against it. It becomes something carried inside it. You are still standing on Earth, but the ground beneath you is no longer a reference point. It has already lost its position in the comparison you were trying to make. The largest star ever discovered is not something you can place in the sky above you. It does not stay distant. The moment you attempt to locate it, the scale breaks, because if it occupied the position of the Sun, its outer layers would already extend far beyond the orbit of the planets you know. Mercury disappears first, then Venus, then Earth. Not as destruction, as inclusion. There is no impact, no collision, no moment where a surface is reached. The planet does not strike anything. It drifts into a region where the idea of a surface begins to dissolve. At first, nothing seems to change. The sky remains, the horizon holds, the ground feels stable. But slowly, the light shifts. The darkness of space above you is replaced by a deepening red glow, not from a single direction, but from everywhere at once. You are not approaching the star. The star is replacing the space around you. What you thought of as empty space begins to thicken, becoming a diffuse field of gas so extended that it has no clear boundary. There is no edge you can point to and say, this is where the star begins. Instead, there is only a gradient, a slow transition from vacuum into atmosphere, from black into red. This is where the comparison fails for the first time. Because a comparison requires separation. It requires distance between two objects, a space where measurement can exist. But here, that space has already been absorbed. The Earth is not next to the star, it is inside the outer regions of it. From orbit, the change becomes clearer, but also more unsettling. The familiar curve of the planet is still there, still turning, still moving along its path. But that path now passes through layers of stellar material that extend across distances larger than entire planetary systems. The orbit has not stopped. It has been enclosed. The Earth continues moving, but that motion is now happening within something else, carried along through regions of gas that stretch for hundreds of millions of kilometers. There is no sudden transition, no boundary crossed, only a gradual immersion into a structure too large to present itself as a single object. The sky is no longer above you. It surrounds you. Every direction becomes the same deep red field, a uniform glow that erases the idea of up and down, of inside and outside. The star does not appear as a sphere because you are too far within its outer layers to see its full shape. You cannot step back from it, because there is no outside left to step into. This is not how you were taught to imagine a star. A star was supposed to be a distant sphere, something you could point at, something that existed separately from you. But at this scale, the star stops behaving like an object and begins behaving like an environment. The difference is subtle at first. Then it becomes absolute. Temperature begins to rise, not suddenly, but steadily, as if the space itself is changing rather than the distance between you and a source. The air does not rush, it deepens. Pressure does not strike, it accumulates. You are not moving toward the star. You are already within it. And this is the moment where the original idea breaks completely. Because the question you started with was how large the star is compared to Earth. But Earth is no longer something you can place beside it. It is a small, moving region embedded within a much larger structure, carried along inside a system that does not recognize the boundary you expected to find. What looked like a size difference was never just a difference in size. It was a difference in category. A planet is something you stand on. A star, at this scale, is something you exist inside. If Earth can exist inside the outer layers of a star, then the next assumption begins to fail. That a star has a clear shape. From a distance, stars appear as spheres, smooth, contained, complete. That image holds only because you are far enough away to compress their structure into a single outline. But inside a star of this scale, that outline disappears, replaced by something uneven, shifting, and deeply layered. The surface is not a surface. What you are moving through is not a boundary, but a depth. Imagine rising upward from the ground, not into empty sky, but into a thickening ocean of gas. The red glow intensifies, not because you are approaching a point, but because every direction around you is becoming denser, hotter, more active. The star does not sit somewhere ahead, it surrounds you as a gradient that deepens with every kilometre. And within that gradient, there are structures. Massive currents of plasma rise and fall over distances larger than entire planets. Regions expand, cool, contract and surge again, forming patterns that would look like slow boiling if you could see them from far enough away. But here, inside it, there is no vantage point that reveals the whole. You are inside a moving field. The ground beneath you is still Earth, still rotating, still carrying oceans and continents, but that motion is now happening inside a much larger flow. The atmosphere of the star does not sit still. It circulates, driven by energy rising from deeper layers, forming vast cells of motion that drift across distances so large they cannot be perceived as movement from within. Stillness returns, but it is different now, because everything around you is moving together. The gas, the radiation, the embedded planet, all of it is part of a shared motion that removes any sense of relative change. There is no wind you can feel, no clear direction of flow, only a gradual shift in conditions that reveals movement over time instead of space. This is the second correction. The star is not a solid object with a defined exterior. It is a structure made of layers, each one blending into the next, each one governed by pressure, temperature, and motion rather than edges. The idea of a sphere only exists when you are far enough away to ignore what is happening inside it. From a distant viewpoint, the star looks smooth. From here, it is uneven and alive. If you could step outward, far beyond the orbit of the outer planets, you would see the star's full scale, a vast red sphere extending across a region that once contained multiple planetary paths. But even then, that sphere would only be an approximation, a simplified shape drawn around something that does not truly have a fixed boundary. Because the outer edge is always shifting. Material expands outward, cools, drifts away, then is replaced by more material rising from below. The star breathes, not in a rhythm you can feel, but in a continuous exchange between inner pressure and outer release. It is not contained in the way you expect. It is constantly redefining its own size. And this is where geometry begins to fail. Because you cannot measure something whose edge is not fixed. You cannot compare its diameter to Earth, when that diameter is a moving target. changing over time as the star expands and contracts, as its outer layers swell outward and then recede. The comparison becomes unstable. What you thought was a number becomes a range, then a shifting region, then something that depends on how you choose to define the boundary in the first place. Earth remains small, but that smallness is no longer the most important feature. What matters is that Earth is moving through layers of a structure that does not present a single surface to measure against. You are not standing beneath a star. You are inside a changing geometry. And if the shape of the star itself cannot be fixed, then the question is no longer how large it is. The question is how something this large manages to hold itself together at all. If the star has no clear surface, then the next question begins to press inward. What is actually holding it together? Because everything around you feels loose, extended, almost fragile. The gas is not packed into a solid boundary. It stretches across enormous distances, thinning gradually as it expands outward. By every ordinary expectation, something this diffuse should drift apart. And yet, it does not. The entire structure remains bound, not by solidity, but by something that does not need contact to act. Gravity does not sit at the surface. It reaches through the entire volume, pulling inward from every direction at once, shaping a structure that has no wall but still holds together. You are inside that pull. The Earth continues its motion, but now that motion is occurring within a field that is constantly drawing material inward, while pressure from below pushes outward. The star exists as a balance between these two forces, an ongoing negotiation between collapse and expansion that never fully resolves. There is no rest state. The outer layers you are moving through are not stable in the way a surface is stable. They are suspended, held in place by a continuous exchange of energy flowing outward from deeper regions you cannot see. Beneath you, far below the layers surrounding Earth, the interior of the star is denser, hotter, more compressed. Energy is being generated and transported outward, pushing against gravity's attempt to collapse the entire structure inward. That outward pressure lifts the outer layers, extending them far beyond what a colder object of the same mass could sustain. This is why the star is so large. Not because it contains more material than smaller stars, but because its material is spread outward, held up by internal energy that inflates its structure. Size here is not accumulation. It is expansion. The star is not a compact object growing larger by adding more mass. It is a system that has become extended, its outer layers lifted into space by the energy moving through it. The result is something that occupies an enormous volume while remaining surprisingly diffuse. From within, that diffusion is difficult to notice. Everything around you feels present, continuous, enclosing. But compared to denser stars, this region contains far less material per unit of space. You are inside something vast, but not solid. A volume, not a shell. And because of that, the structure becomes sensitive. Small changes in internal energy can cause large changes in size. The star can expand further, pushing its outer layers outward, or contract slightly, pulling them back in. Its boundary breathes. Not in a rhythm you can track moment by moment, but across spans of time that reshape its entire scale. The distance from its center to its outer layers is not fixed. It is a shifting result of the balance between inward pull and outward pressure. This introduces a deeper instability. Because the larger the star becomes, the more loosely its outer layers are held. The pull of gravity weakens with distance, while the outward push continues, creating regions where material can begin to drift away entirely. You are near that threshold. The place where being part of the star and escaping from it become almost the same condition. Gas around you moves slowly outward, not as a violent ejection, but as a gradual release, slipping away from the star's hold into the surrounding space. The star is losing itself. Even as it appears immense, Even as it fills the space where planets once moved freely, it is not a permanent structure. It is a temporary arrangement of matter, stretched outward to the point where holding together becomes increasingly difficult. What looks overwhelming is already beginning to thin. And this is the hidden structure you could not see from a distance. A star of this size is not simply larger, it is closer to coming apart. The more it expands, the closer it moves toward a state where it can no longer contain itself. So the question shifts again. Not how large it is, but how long something this large can continue to exist before the forces holding it together begin to fail. If the star is already struggling to hold itself together, then what happens to everything inside it begins to change as well. Because Earth is not just inside a large object. It is inside a system that is slowly coming apart. The outer layers around you continue to drift, not in a sudden collapse, but in a steady outward release. The gas thickens and thins in waves, carried by pressure rising from below and weakened by gravity's fading grip at these distances. The environment is not stable. It is transitional. At first, the changes are subtle. Temperature increases, but not evenly. Pockets of hotter gas move past regions that are cooler, creating gradients that shift over time. The red glow deepens, then softens, then deepens again, as if the space itself is breathing. But this is not rhythm. It is imbalance. The Earth continues its path, still orbiting where the Sun once held it, but that orbit is no longer clean. It is no longer a path through empty space. It is a trajectory through a medium, through layers of stellar material that introduce resistance, drag, and distortion. The orbit begins to decay. Not instantly, not catastrophically, but inevitably. As the planet moves through this extended atmosphere, it loses energy. The motion that once kept it in a stable path begins to weaken, its trajectory slowly tightening, drawing it deeper into the star's structure. You are no longer circling outside. You are sinking inward. From the surface, nothing feels like falling. The ground still holds. Gravity still pulls you downward toward Earth's center. But the system around you is shifting, and that shift is changing where Earth itself will be carried over time. The reference frame has changed again. What you thought of as a stable orbit is now a temporary condition inside a much larger flow. The star's outer layers are not passive. They interact, exerting forces that alter motion, that reshape paths, that slowly erase the clean geometry of orbital mechanics. The path is no longer yours. It is being rewritten. Above you, or what used to be above you, massive currents of gas continue to rise and fall. Some of that material escapes entirely, drifting away into surrounding space. Some of it falls back inward, pulled again by gravity, feeding deeper layers of the star. You are inside a circulation. Matter moves outward, then inward, then outward again, creating a system where nothing remains fixed for long. Even the star itself is not holding a steady shape. It expands, releases, contracts slightly, then expands again, each cycle altering the conditions within. This is not a static environment. It is an evolving one. And within that evolution, Earth becomes increasingly out of place. A dense, solid body moving through a diffuse, shifting medium, interacting in ways that slowly strip away the conditions that allowed it to remain intact. The atmosphere of Earth would begin to change first, heated, expanded, and gradually removed as it interacts with the surrounding stellar gas. The boundary between planet and star becomes less distinct, not through a single event, but through continuous exchange. The edges blur, not just of the star, but of the planet itself. Over time, the distinction between what belongs to Earth and what belongs to the star begins to fade. Material is exchanged, energy is transferred, and the idea of a separate object becomes harder to maintain. This is the consequence of scale. Not just that something larger contains something smaller, but that the larger system begins to redefine the smaller one. Earth is no longer acting independently. It is being absorbed into a process. And that process does not stop at planets. It extends through the entire structure of the star, through its layers, through its gradual loss of material, through its slow movement toward a state where holding itself together becomes impossible. What you are inside is not just large. It is temporary. And everything within it is part of that temporary condition, carried along as the star moves toward the limits of what its own structure can sustain. So the question shifts again. If even something this large cannot remain stable, then what kind of system produces stars like this in the first place? If a star this large is unstable, expanding, losing material, and slowly coming apart, then it cannot be understood as an isolated object. It has to belong to a process, because something had to create it in this state, and something will carry it out of it. The star you are inside was not always this large. It did not begin as a vast, diffuse structure stretching across planetary orbits. It began smaller, denser, more contained, like other stars that remain stable for far longer periods of time. This size is a phase, a condition it has entered, not a permanent identity it has always held. Somewhere earlier in its life, the balance between gravity and internal energy shifted. The energy pushing outward increased, lifting the outer layers, inflating the star beyond its previous boundaries. The structure expanded, not because it gained more mass, but because it redistributed what it already had. The star changed category. It moved from a stable star to something more extreme, a hypergiant, a phase where size increases as stability decreases. From the outside, this looks like growth. From the inside, it feels like loosening. The layers around you are extended because they are no longer held as tightly as before. Gravity still pulls inward, but it is now competing with internal processes that are pushing outward with greater intensity. The result is not balance, but tension. And tension does not last. This is where the star becomes part of a larger system, not just a single object floating in space, but a stage in a sequence, a step in a transformation that all massive stars undergo as they evolve. You are not inside a final form. You are inside a transition. The material drifting away from the outer layers is not simply being lost, it is being returned to the surrounding space, enriching it, changing it, preparing it for what comes next. The star is not just existing, it is contributing to a cycle. Matter leaves the star and enters the interstellar medium, the vast regions between stars where gas and dust accumulate. Over time, those regions will collapse again under gravity, forming new stars, new systems, new structures. The star feeds the system that will replace it. And in that system, size is not the defining feature. Because the largest stars do not last the longest. They burn faster, evolve more quickly, and reach instability sooner. The very scale that makes them overwhelming also makes them temporary. This reverses the assumption you began with. Larger does not mean more enduring. Larger means closer to change. From a distance, this star appears dominant, overwhelming, incomparable. But within the system it belongs to, it is only one stage, one configuration of matter and energy, passing through a sequence that continues beyond it. The star is not the center of the story. It is a moment within it. And that moment is defined by imbalance, by expansion, by the gradual loss of the structure that once held it together more tightly. You are still inside it, still carried along within its outer layers, but now the meaning of that position has changed. You are not inside a fixed object. You are inside a phase of a system that is already moving towards something else. And if this star is only one stage in a larger process, then the scale you have been trying to understand is no longer just about one star compared to one planet. It is about how entire systems create, expand, and dissolve structures that briefly reach sizes your mind struggles to hold. If this star is only a phase, then its scale cannot be understood from inside it. You have to leave it. Not physically, but perceptually. Because as long as you remain embedded within its layers, everything feels continuous, surrounding, without edge. To understand what it is, you need distance again, a frame that allows it to be seen as part of something larger. So the view shifts outward, far beyond the orbit that once defined Earth's path, far beyond the outer reach of the star's extended atmosphere. The structure begins to resolve into a shape again. A vast red sphere, uneven at its edges, its surface not smooth but textured, alive with motion. From here, it looks contained. But that containment is an illusion of distance. Around it, other stars appear, some smaller, some brighter, some more stable. The Sun, if placed in this view, would shrink into something almost negligible, a small, steady point compared to the swollen scale of the hypergiant. The comparison returns. But it has changed meaning. The Sun is no longer a standard. It is a different category entirely. A star that has not entered this phase, a star that remains compact, controlled, and far more stable. Size no longer defines importance. It defines condition. The hypergiant dominates space visually, but its structure is loose, extended, and unstable. The smaller stars around it hold their shape more tightly, their gravity containing their material more effectively, their lifetimes stretching far beyond what this massive structure can sustain. The larger one is not stronger. It is more temporary. From this distance, you can begin to see the imbalance directly. The outer layers of the star ripple and shift, expanding outward in irregular patterns. Material drifts away, forming faint streams that extend into the surrounding space, barely held by the star's gravity. It is shedding itself. Not in a single event, but continuously, slowly, almost imperceptibly over short timescales. Over longer periods, the change becomes undeniable. The star grows, then loses, then reshapes, never settling into a final form. It cannot remain as it is. And now, with distance restored, the original comparison can be attempted again. Earth, a small, dense planet orbiting a stable star, versus a hypergiant whose size can swallow entire planetary systems. But the comparison no longer holds the same weight. Because the hypergiant is not a fixed object, it is a moving target, a structure that changes over time, its radius expanding and contracting, its outer layers drifting away. You cannot measure it once. You have to follow it. And as you follow it, another realization begins to form. This star is not unique in isolation. It exists among others, scattered across the galaxy, each one representing a similar phase, a similar expansion, a similar approach toward instability. They are not the norm. They are the extremes. Rare, short-lived, and structurally fragile compared to the vast number of smaller, more stable stars that fill the galaxy. From this distance, the star's size is still overwhelming. But its meaning has changed again. It is no longer the largest thing you can imagine. It is one example of how far a star can stretch before it begins to lose itself. And if stars can reach this scale only briefly, then the question shifts once more. What limits how large a star can become before it can no longer hold together at all? If there is a limit to how large a star can become, it does not appear as a boundary you can see. It appears as a failure you can detect. From a distance, the hypergiant still looks immense, dominating its region of space, extending far beyond the scale of ordinary stars. But now that you are no longer inside it, the signs of strain become clearer. The outer layers are not just extended. They are barely held. Gravity weakens with distance, and at these scales, that weakness becomes critical. The pull that once kept the star tightly bound now struggles to retain material at its edges. Gas drifts outward, slow enough to seem stable, but persistent enough to reshape the star over time. The edge is not an edge. It is a slow escape. What you are seeing is not a finished structure, but a system approaching its limit. The larger it becomes, the more difficult it is to maintain cohesion. Expansion increases surface area, reduces density, and weakens the forces that hold everything together. Size creates fragility. This is the inversion that was hidden from you at the beginning. The larger the star grows, the less stable its outer layers become. The very scale that makes it overwhelming also pushes it towards structural failure. From this perspective, the star looks less like a solid body and more like a cloud attempting to remain a sphere. Its shape persists only because gravity continues to pull inward, but that pull is no longer strong enough to enforce a sharp boundary. It is holding, but only just. And that balance cannot be sustained indefinitely. Inside the star, deeper regions remain dense, hotter, more tightly bound. Energy continues to move outward, driving expansion, lifting material toward the edge where gravity's grip is weakest. This outward flow is what allows the star to reach such enormous size. But it also ensures that it cannot remain that way. The more energy pushes outward, the more the structure inflates. The more it inflates, the weaker its outer layers become. The weaker those layers become, the more material is lost. The process feeds itself. Expansion leads to loss. Loss leads to further instability. Instability leads to transformation. The star cannot stabilize at this scale. It can only pass through it. And now the comparison with Earth dissolves even further. Earth is small but stable. Its structure is tightly bound, its material held firmly by gravity, its shape defined and persistent. The hypergiant is vast but temporary. Its structure is extended, its material loosely held, its shape constantly changing. The difference is no longer just size. It is permanence versus transition. From here, you begin to see why the largest stars are not the most dominant features of the galaxy. They are visible, dramatic, overwhelming, but they are also fleeting, existing for a fraction of the time that smaller stars endure. They appear as peaks, brief expansions into extreme scale before the system moves on. And beyond this star, scattered across the galaxy, there are others at different stages of this same process. Some are smaller, just beginning to expand. Others are larger, closer to collapse, shedding more material, their structure becoming increasingly unstable. You are not looking at an exception. You are looking at a pattern. A phase that massive stars pass through as they evolve, expanding outward until the forces that support that expansion begin to fail. And that failure does not happen all at once. It begins at the edges. It begins where gravity is weakest. It begins where the star becomes too large to hold itself together. Which means the true limit of size is not defined by how big a star can grow. It is defined by how much of itself it can lose before it stops being that star at all. If the limit of a star is defined by how much of itself it can lose, then the space around it is no longer empty. It is filled with what the star has already given away. From a distance, the hypergiant appears surrounded by a faint, extended haze, a region of gas and dust stretching far beyond its visible edge. This is not background. It is the star's own material, slowly released, carried outward into the surrounding environment. The star is not contained within its boundary. It extends beyond it. What you are seeing is the beginning of a larger structure, one that does not belong to the star alone. The material drifting away does not vanish, it accumulates, mixes with the surrounding medium, and becomes part of a broader environment that exists between stars. The space between stars is not empty. It is filled with what stars leave behind. Clouds of gas, enriched by elements formed deep within stellar interiors, begin to spread across vast regions. These clouds are not uniform. They thicken in some areas, thin in others, shaped by the motion of stars, by gravitational fields, by the energy released as stars expand and shed their outer layers. You are no longer looking at a single object. You are looking at an environment. The hypergiant becomes one contributor among many, feeding this expanding medium with material that will not remain where it is. Over time, gravity will begin to act on these clouds, pulling denser regions inward, forming new structures from what was once part of a dying star. The star is not just losing mass. It is redistributing it. And in that redistribution, a larger pattern emerges. Stars form from these clouds, evolve, expand, shed material, and return it to the same environment that will later create new stars. The process repeats, but not identically. Each generation of stars changes the composition of the medium, adding heavier elements, altering the conditions under which new stars form. The environment becomes more complex over time, shaped by countless cycles of formation and loss. This is where the idea of scale shifts again. The largest star is no longer the focus. It is one moment in a continuous exchange of matter and energy that extends across entire regions of space. From this perspective, size becomes secondary. What matters is participation. The hypergiant participates in a system that extends far beyond its own structure, contributing material, energy, and motion to an environment that connects multiple stars across vast distances. The star is not isolated. It is embedded. And within that embedded system, the distinction between one star and the space around it begins to blur. Material flows outward, mixes, and later collapses into new forms. The boundary between star and environment becomes part of a larger cycle, one that does not preserve individual structures indefinitely. Nothing remains separate for long. The star dissolves into the environment, and the environment eventually forms new stars. This is the hidden environment you could not see when you were standing on Earth, trying to compare one object to another. Because the comparison assumed isolation, it assumed that the star existed on its own, separate from everything else. But in reality, it exists as part of a network of exchange, a system where matter moves between structures, where size is temporary, and where even the largest forms are only brief configurations within a much larger process. And if the star is only one node in this environment, then the question shifts again. What larger structure contains this entire cycle of formation, expansion, and dissolution? If this cycle of formation and loss repeats across space, then it is not happening in isolation. It is happening inside a larger structure. What you have been following, a single star expanding, shedding, dissolving into its surroundings, is only one local expression of a pattern that extends across the entire galaxy. The view pulls back again. Not just beyond the star, not just beyond its surrounding cloud, but across the region of space where many such clouds and stars exist together, moving, interacting, shaping one another over time. The galaxy begins to take form. Not as a static collection of stars, but as a dynamic system where matter flows, gathers, and redistributes across enormous distances. The hypergiant is now one point among billions. But it is not evenly placed. Stars are not scattered randomly. They follow structures, patterns shaped by gravity on a much larger scale. Spiral arms extend across the galaxy, regions where gas is denser, where star formation is more active, where the cycle you observed becomes more concentrated. The star you are inside belongs to one of these regions. It was formed there, it expanded there, and it is now contributing material back into that same structure. The cycle is localized, but the pattern is global. Across the galaxy, Countless stars are at different stages of this same process. Some are forming from collapsing clouds. Some are stable, burning steadily. Others, like the hypergiant, are in late stages, expanding, losing mass, approaching transformation. All of them are connected. Not directly, but through the medium they share, through the gas and dust that moves between them, through the gravitational field that shapes their motion across the galaxy. You are no longer following a single object. You are tracing a flow. Matter moves from cloud to star, from star to cloud, across distances measured in light years, guided by structures that are invisible from any single point inside the system. The galaxy is not a collection of things. It is a circulation. And within that circulation, the idea of the largest star begins to lose its meaning, because size does not define position in the system. Movement does. The hypergiant, despite its enormous scale, is still carried along with the motion of the galaxy, orbiting its center, moving through spiral arms, passing through regions of higher and lower density over time. It is not stationary. It is being transported. This introduces another layer of instability, not just internal, but external. The environment around the star changes as it moves, influencing how it evolves, how it loses material, how its outer layers interact with the surrounding medium. The star does not control its context. It is shaped by it. From this scale, the original comparison between Earth and the largest star becomes almost irrelevant. Both are part of the same galactic system, both moving through it, both subject to the same larger forces, though in very different ways. The difference is not just size. It is role. Earth is part of a stable system around a relatively steady star. The hypergiant is part of a transitional phase within a larger cycle of formation and loss. But both are carried by the same structure. Both are inside the same galaxy. And that galaxy is not still. It rotates slowly, carrying stars, clouds, and entire systems along paths that take hundreds of millions of years to complete. You are not just inside a star. You are inside a galaxy that is moving. And if this entire cycle of stars forming, expanding, and dissolving is happening inside something even larger, then the question shifts once more. What carries the galaxy itself? If the galaxy itself is moving, then everything you have followed so far, the star, the clouds, the cycles of formation and loss, is being carried by something larger still. The view widens again. The spiral structure of the galaxy begins to shrink, not because it is small, but because your frame of reference is expanding beyond it. The arms that once seemed vast become a single rotating pattern, a disk of stars and gas turning slowly through space. But that space is not empty. It contains other galaxies. From this distance, your galaxy is no longer unique. It is one among many, scattered across a region known as a group, bound together by gravity, moving in relation to one another. The hypergiant star you began with is now invisible. Even the sun is gone from view. What remains are entire galaxies, each containing billions of stars, each carrying its own cycles of formation and dissolution. And they are not still. They drift, accelerate, curve toward one another, pulled by shared gravitational influence across distances so large that individual stars no longer matter. The scale has shifted again. From objects to systems to collections of systems. Your galaxy is part of a local group, a small gathering of galaxies bound together, moving through space in a slow gravitational dance. Some approach each other, some recede, their motions tracing paths defined by mass distributed across vast regions. You are no longer tracking a star. You are tracking motion across galaxies. And within this motion, a new pattern begins to appear. Galaxies are not distributed evenly. They cluster, forming larger groupings, structures that extend across millions of light years, connected by gravity, by shared movement, by the distribution of matter on scales far beyond anything you have seen before. The system repeats. Small structures inside larger ones. Stars inside galaxies. Galaxies inside groups. Groups inside clusters. Each layer carries the one below it, embedding smaller systems within larger flows of motion. This is the hierarchy you could not see from Earth. Because from the ground, everything appeared separate. The planet, the star, the sky, each seemed like its own object. But now, every layer you have passed through reveals that nothing was ever isolated. Everything is nested. Everything is carried. The galaxy itself moves through a cluster, a larger assembly of galaxies bound together, their combined gravity shaping the motion of everything within. And even this is not the final layer. Because clusters connect to other clusters, forming extended structures that stretch across unimaginable distances, patterns of matter that define the large-scale structure of the universe. From here, the idea of the largest star becomes distant, almost irrelevant. Not because it is small, but because it belongs to a scale that is no longer dominant in this frame. It is one element inside a system that extends far beyond it. The comparison you began with has been absorbed into a hierarchy. Earth to star, star to galaxy, galaxy to cluster, each step dissolving the importance of the previous one. And yet, every layer remains connected. The hypergiant star still exists, still expanding, still losing material, but its role is now part of a chain that leads outward into structures that define the universe itself. You are no longer asking how large the star is compared to Earth. You are asking where that star fits in a system that has no clear edge. And if every structure you have seen is part of something larger, then the question becomes unavoidable. Does this hierarchy end? Or does it continue beyond what you can observe? If the hierarchy continues, then what you have been building is not a ladder. It is a network. From this distance, the clusters of galaxies begin to reveal connections between them, not through direct contact, but through distribution. Galaxies gather along vast strands, leaving enormous regions between them where very little matter exists. The universe is not filled evenly. It is structured. What look like scattered galaxies become something more organized, a pattern stretching across hundreds of millions of light years, where matter is drawn into filaments, long threads of galaxies and dark matter that weave through space. Between them, there are voids. Immense regions where almost nothing exists. The clusters you saw are not isolated groups, they are nodes, intersections where these filaments meet, where matter concentrates, where gravity has drawn material together over immense spans of time. Your galaxy is inside one of these threads, carried along it, moving within a structure you could never perceive from inside it. The hypergiant star you began with still exists, but now it is embedded within a galaxy, which is embedded within a filament, which is part of a network that stretches across the observable universe. The scale has shifted again. But this time, it is not just larger. It is different in form. The universe is not expanding into emptiness in a uniform way. It is organizing itself into patterns, where matter gathers along invisible scaffolds shaped by gravity and the distribution of dark matter. This is not a collection of objects. It is an architecture. And within this architecture, motion is no longer just orbital or local. Entire galaxies move along these filaments, drawn toward dense regions, slowly shifting position over billions of years. You are inside that motion, even now. The Earth, the star, the galaxy, all of it is being carried along paths defined by structures you cannot see from within. Stillness is gone completely. At every scale, something is moving, being pulled, being carried, through a system that extends beyond direct observation. This is the network that contains everything you have seen so far. And yet, even this is not the final boundary. Because the filaments themselves are part of something larger, a pattern that emerges when you step back even further, when you stop looking at individual strands and begin to see the full distribution of matter across the observable universe. The structure begins to resemble something unexpected. Not a uniform spread, not random scattering, but a web. A cosmic web where filaments intersect, where clusters form nodes, where voids expand between them, creating a pattern that repeats across the largest scales we can observe. Everything you have followed is inside this web. Every star, every galaxy, every cluster. All of it suspended within a structure that defines where matter exists and where it does not. The comparison you began with has dissolved completely. Earth and the largest star are no longer opposing points on a scale. They are both embedded within a network that determines their position, their motion, and their role in a system far beyond their individual size. And within this web, another realization begins to emerge. The largest structures are not defined by objects. They are defined by absence, by the vast voids that separate the filaments, by the emptiness that shapes the distribution of everything else. Which means the final question is no longer about size at all. It is about boundaries, and whether the structure you are seeing has one. If the largest structures are defined by absence, then what you have been looking at is only half of the system. Because the voids are not empty in the way you first imagined. They are part of the structure. From this distance, the cosmic web reveals its full pattern. Filaments of galaxies stretch across space, intersecting at dense nodes, while vast regions between them remain nearly devoid of matter. But these voids are not simply gaps. They shape the entire architecture. Matter flows away from them. Gravity pulls material toward the filaments, leaving the voids to expand, to grow larger as the denser regions become more concentrated. Over time, the contrast increases. The web becomes more defined, not because more matter is created, but because it is redistributed. The structure sharpens. And within that sharpening, motion takes on a new meaning. Galaxies are not just orbiting locally, they are drifting along gradients defined by this large-scale structure, moving toward regions of higher density, away from expanding voids. The motion is subtle on human timescales, but over billions of years, it reshapes the entire map. You are inside that drift. Even now. The Earth, the star you began with, the galaxy that contains it, all of it is moving through this network, guided by forces that operate across distances so large they erase any sense of fixed position. There is no center here. No single point that defines the system. Every location is part of the same expansion, the same redistribution, the same gradual evolution of structure across the observable universe. This is the second fracture. Because earlier you lost the idea of comparison, now you lose the idea of location. You are not somewhere fixed. You are somewhere temporary within a structure that is changing. The cosmic web itself is evolving. Filaments shift, clusters merge, voids expand. The distances between structures increase as the universe continues to expand, stretching the web outward, thinning connections, isolating regions over time. The system is not static. It is unfolding. And within that unfolding, the largest star ever discovered becomes something else entirely. Not an extreme point on a scale, not a final example of size, but a small event within a much larger process that spans the entire observable universe. its expansion, its instability, its eventual dissolution. All of it is part of a chain that connects to the formation of galaxies, to the distribution of matter, to the evolution of the cosmic web itself. The star does not stand apart. It participates. And now, with this scale in view, the original question becomes difficult to even hold in place. How large is the star compared to Earth? The comparison no longer fits the system you are looking at, because Earth is not a fixed reference. The star is not a fixed object, and the universe they exist in is not a fixed structure. Everything is moving, evolving, redistributing across layers of scale that replace one another as your perspective widens. You are not observing from outside this system. You are inside it. Carried along by the same forces, embedded in the same structure, part of the same unfolding pattern that connects the smallest scales you can stand on to the largest structures you can imagine. And if there is no fixed position, then the final shift begins to settle in. The place you thought you occupied was never stable. If your position was never stable, then neither was your sense of scale. Because scale depends on where you believe you are standing. At the beginning, you stood on Earth and looked outward, comparing one object to another, assuming distance, assuming separation, assuming that you could place things side by side and measure them. But that position has dissolved. You are not outside the system observing it. You are inside it, moving with it. The Earth carries you. The Earth orbits the Sun. The Sun moves through the galaxy drifts along a filament, and that filament is part of a structure that is expanding and reshaping over time. There is no fixed ground beneath any of it. Only shared motion. This is where the last familiar idea begins to break. Stillness. Because everything you have followed, from the surface of Earth to the largest structures in the universe, is in motion. But that motion is hidden by coordination. Objects near you move together, masking the movement, creating the illusion that nothing is happening. Stillness is agreement. You do not feel the Earth rotating because everything around you rotates with it. You do not feel the Earth orbiting because the atmosphere, the ground, and your own body share that motion. And now, you do not feel the galaxy moving or the cosmic web shifting because everything you can observe is part of the same flow. Motion disappears when it is shared. This is why the largest star once seemed so separate. It appeared as an object far away, something you could compare against your own position. But that perception depended on ignoring the motion that connects everything. The star was never isolated. It was always part of the same system carrying you. And now, the comparison dissolves completely. Because there is no stable point from which to make it. You cannot stand still and measure something that is moving with you. You cannot step outside the system to place Earth and the star side by side. The frame you need does not exist. The comparison required a fixed observer. There is no fixed observer. This is the final correction of perspective. Not that the star is larger than Earth, not that it contains planetary orbits, not that it is unstable or temporary, but that the entire act of comparison depends on a position that was never real. You were always moving, always embedded, always part of the system you were trying to observe. And once that is understood, the scale of the star no longer feels like something external. It becomes something contextual, something that exists within the same structure that defines your own motion, your own position, your own existence. The largest star is not something you stand apart from. It is something that exists within the same moving network that carries you. And within that network, size does not grant independence. It does not create separation. It only marks a temporary condition within a system that never stops changing. which means the final shift is no longer about the star. It is about you, and the realization that the place you thought you occupied, the ground you believed was stable, the position you assumed was fixed, was never separate from the motion of everything else. If your position was never separate from the system, then neither was your scale. Because scale was something you assigned from a fixed point that never existed. At the beginning, Earth felt like a base, a place you could stand and measure outward from. The largest star felt like something distant, something you could compare against that base. But that structure depended on a boundary that has now dissolved. There is no base, only layers of motion. The Earth is not a foundation. It is a moving surface, carried by orbital paths, embedded in gravitational flows that extend far beyond what you can perceive from its surface. And those flows do not stop at the edge of the solar system. They extend through the galaxy, through the filament, through the expanding structure of the universe itself. You are not anchored. You are carried. This is where scale inverts for the final time. Because what once felt large and dominant, the hypergiant star, is now just another moving region within this network. Its vast size does not give it control over the system. It does not define the structure. It is shaped by it, carried by it, and eventually dissolved back into it. Size does not grant independence. It does not create stability. It only changes how long a structure can maintain its form before it becomes something else. The star expands, loses material, and disappears into the environment that surrounds it. The environment forms new stars, new systems, new structures that repeat the process. Nothing remains fixed long enough to become a true reference point. Everything is temporary, even the largest forms. From this perspective, the difference between Earth and the largest star is no longer meaningful in the way you first imagined. One is not simply smaller, and the other is not simply larger. They are both participants. Different scales, different durations, different roles within the same system. Earth is compact, stable for long stretches of time, moving within a relatively steady environment. The hypergiant is extended, unstable, existing briefly before transforming into something else. But both are carried. Both are embedded. Both are expressions of the same underlying structure that moves matter through phases of formation, expansion, and dissolution. The comparison collapses completely here, because you are no longer comparing objects. You are observing transitions. And transitions cannot be measured the way objects can. They do not have fixed edges, fixed sizes, fixed positions. They exist as changes over time, as movements through states, as temporary configurations within a larger flow. The largest star is not a final answer. It is a moment in that flow. And so is Earth. And so are you. Which means the final understanding is not about how large something can become. It is about how everything you observe, no matter how large or small, is part of a system that does not stop moving, does not hold still long enough to be fully measured, and does not provide a fixed place from which to compare anything at all. You were never outside it. You were always inside the motion. If everything you have followed is part of a continuous motion, then size becomes something else entirely. Not a measurement. A condition. The largest star ever discovered is no longer the end point of a scale. It is not the ultimate comparison, not the final example of how big something can be. It is a temporary state, one arrangement of matter stretched outward under specific conditions, held briefly before those conditions change again. Size is not fixed. It is negotiated. The hypergiant expands because internal energy pushes outward, lifting its outer layers into space. It contracts when that balance shifts. It loses material when gravity can no longer hold those layers in place. Its size is not something it owns. It is something it passes through. The same is true at every level you have seen. Galaxies expand and merge, clusters shift and reorganize, filaments stretch as the universe itself continues to expand. Even the voids grow, widening the distances between structures over time. Nothing holds its size permanently. Everything changes scale. This is the final reclassification. Because the question you began with assumed that size was a stable property, that Earth had a size, the star had a size, and the difference between them could be measured in a meaningful, lasting way. But that assumption required stillness. It required fixed boundaries. It required objects that remain the same long enough to be compared. None of those conditions exist. The Earth changes over time, though slowly. The star changes more rapidly, expanding and dissolving. The galaxy evolves, the cosmic web stretches. The universe itself continues to expand, altering distances at the largest scales. The frame is never stable, which means the measurement is never final. The largest star is not the largest forever. It is the largest within a moment, within a set of conditions that will not last. There may have been larger stars in the past. There may be larger ones in the future. The title itself is temporary. Even the idea of largest is unstable. It depends on when you look. From this perspective, the comparison between Earth and the largest star becomes something different, not a ratio, not a number, but a contrast between two states within a moving system. Earth represents a tightly bound, relatively stable configuration. The hypergiant represents an extended, unstable configuration approaching transformation. Both are real. Both are temporary. And both exist within a structure that continues to evolve, redistributing matter and energy across scales that replace one another as your perspective widens. You are not looking at fixed things. You are looking at phases. And those phases do not align neatly for comparison. They overlap, shift, and dissolve into one another, making any attempt to define a final scale incomplete the moment it is made. The largest star ever discovered is not an answer. It is a moving boundary. A brief expansion into extreme scale that reveals what happens when structure is pushed to its limits, when gravity and energy reach a balance that cannot hold, and when matter begins to spread outward into the system that will eventually reshape it again. And within that system, there is no final size to reach. If there is no final size to reach, then the idea of extremes begins to collapse. Because extremes only exist when there is a stable scale to measure against. At the beginning, the largest star felt like an endpoint, the far edge of what could exist, something that defined the upper limit of size. But now that scale has dissolved into motion, into phases, into conditions that change over time. That endpoint disappears. There is no edge to arrive at. Only transitions to pass through. The hypergiant is not sitting at the top of a ladder. It is passing through a region of possibility where matter has been extended as far as it can be held together under its current conditions. Beyond that, it cannot remain what it is. It must change. And that change is not optional. It is built into the structure of the system itself. When a star expands too far, when its outer layers become too diffuse, when gravity can no longer maintain cohesion, the structure begins to break down. Not suddenly, but inevitably. The star will shed more of its mass, its outer layers drifting away into the surrounding medium. Its core will continue evolving, moving toward a state that is no longer defined by expansion, but by collapse, by transformation into something denser, more compact, more tightly bound. The direction reverses. Expansion gives way to contraction. The largest form does not persist. It transitions into something smaller, denser, and fundamentally different in structure. This is the inversion you could not see at the beginning. The path of increasing size does not continue forward. It turns back. Stars do not grow without limit. They expand until they reach instability. Then they transform, shedding their outer layers, leaving behind cores that no longer resemble the structure you were inside. The hypergiant is not the final stage. It is a turning point. And beyond that point, the system produces objects that are far smaller in size, but far more extreme in density, where matter is compressed into states that no longer resemble the diffuse layers you moved through earlier. Size decreases. Intensity increases. The system does not reward expansion. It cycles through it. From this perspective, the largest star becomes less important than what comes after it. Its scale is not the ultimate feature. Its instability is. Its inability to remain that large is what defines its place in the system. The star reaches outward. Then it lets go. And what remains is no longer defined by how far it extended, but by how it collapsed, how its core restructured, how its material was redistributed into the environment and into new forms. This is the deeper pattern that replaces the original comparison. Not Earth versus star, but stability versus transition. Expansion versus collapse. Loose structure versus dense structure. And within that pattern, your own position becomes clearer. You are not aligned with the largest forms. You are aligned with the stable ones. Earth exists because it is part of a system that has not yet entered this extreme phase. It orbits a star that remains relatively compact, relatively controlled, far from the instability that drives hypergiants to expand and dissolve. You are inside a quieter region of the same system. A region where change is slower, but not absent, because the system does not stop. The same processes that create hypergiants, that expand them, that dissolve them, are part of the larger cycle that will continue shaping the galaxy, the interstellar medium, and eventually, new generations of stars and planets. Nothing escapes the cycle. Only the timing changes. Which means the largest star was never the destination you thought it was. It was a signal. A brief expansion that reveals what happens when structure reaches its limit and begins to turn into something else. If the largest star is only a turning point, then what you thought of as scale is no longer a ladder. It is a cycle. You began with the idea of something becoming larger and larger, as if size were a direction you could continue moving toward. But now that direction has curved back on itself. Expansion leads to instability. Instability leads to release. Release leads to collapse. And collapse creates something else entirely. The system does not move upward. It moves through states. The hypergiant expands until it cannot hold together. It sheds its outer layers into the surrounding medium. Its core contracts, becoming denser, more compact, entering a phase where size is reduced, but internal intensity increases beyond what the extended structure could sustain. The largest form disappears. What remains is smaller but more extreme. This is where scale inverts again. Because what once felt like the most powerful expression of a star, its enormous size, is replaced by something that occupies far less space, but holds far more energy within it. The system shifts from visible extension to hidden concentration, from distance to density. And this inversion does not stop at stars. Across the structures you have seen, similar patterns appear. Galaxies form from diffuse clouds, then condense into rotating systems. Clusters gather galaxies into tighter gravitational bindings. Even the cosmic web evolves as matter flows into denser regions, leaving voids behind. The universe does not expand uniformly. It organizes. And within that organization, the extremes you notice are not final states. They are transitions between phases of distribution and concentration. The hypergiant is one such transition. A brief moment where matter is stretched outward before being pulled back into new configurations. You are not witnessing a peak. You are witnessing a passage. And this changes the meaning of everything you have seen. The largest star is no longer impressive because of its size alone. It is significant because it reveals the limits of expansion, the point at which structure can no longer sustain itself in that form. It shows you where one phase ends and where another begins. From this perspective, Earth and the hypergiant are no longer opposites on a scale. They are different positions within the same cycle, different expressions of matter under different conditions, moving through phases that connect them rather than separate them. You are not standing outside this cycle. You are inside it. Even now, the system that formed Earth, that formed the Sun, that formed the elements within your body, has passed through similar phases, through expansion, collapse, redistribution, and recombination across vast spans of time. What you are made of was once inside stars. Some of it inside stars far larger than the one you began with. The cycle does not just surround you. It includes you. And once that is understood, the comparison dissolves completely. Because you are not comparing Earth to a star. You are recognizing that both are temporary configurations within a system that never stops moving between expansion and collapse, between extension and concentration, between forms that appear stable and those that exist only briefly before transforming again. There is no final scale to reach, only phases to pass through. And every structure, no matter how large or small, is already on its way to becoming something else. If every structure is already on its way to becoming something else, then permanence was never part of the system. It was only an illusion created by timescale. From the surface of Earth, change feels slow, almost absent. Mountains appear fixed, oceans seem constant, the sky repeats its patterns. But this stability exists only because the processes shaping them move at speeds that are difficult to perceive within a human lifetime. The system has always been changing. You were just not positioned to see it. The hypergiant made that change visible. Its expansion, its instability, its loss of structure, all of it happened at a scale and intensity that forced the system into view. It revealed that size does not protect against transformation. It accelerates it. Larger stars evolve faster, burn through their internal processes more quickly, and reach instability sooner. Their immense scale is not a sign of endurance, it is a sign of urgency. They do not last. They pass through their phases rapidly, shedding material, collapsing, transforming into new structures that no longer resemble what they were. From this perspective, rarity begins to matter. The largest stars are not common, they are brief. They appear only under specific conditions, exist for short periods, and then disappear into the broader system. You are seeing an extreme, not a norm. Most stars do not become hypergiants. Most remain smaller, more stable, existing for far longer durations, contributing to the system in slower, more gradual ways. The universe is not dominated by extremes. It is defined by what lasts. And what lasts are not the largest structures, but the most stable ones, the configurations that can persist without rapidly transforming. This reframes the entire idea of significance. The hypergiant feels important because it is overwhelming, because it breaks your sense of scale, because it forces a reclassification of what a star can be. But within the system, its role is not to dominate. It is to transition. To take matter to an extreme state, then return it to the environment, allowing new structures to form from what it releases. It is a brief expansion within a much longer cycle. And that cycle is not rare. It is everywhere. Across the galaxy, across the cosmic web, across the entire observable universe, matter is constantly moving through these phases, forming, expanding, dissolving, and reforming again. Nothing is isolated. Nothing is final. Every structure you have followed, from Earth to star to galaxy to filament, exists within this continuous process of change. And within that process, your original question has transformed completely. Not how large is the largest star compared to Earth, but how scale itself behaves in a system where nothing remains the same long enough to be fixed in place. The answer is no longer a number. It is a realization. That size is not something you measure once. It is something that emerges, changes, and disappears as the system continues to move. And within that movement, even the largest forms are only temporary expressions of a structure that never stops reshaping itself. If size is something that emerges and disappears, then there must be limits to how far that emergence can go. Not a final size, but a boundary of possibility. The hypergiant you began with feels extreme, as if it has stretched matter to its furthest reach. But that reach is not unlimited. It is defined by the same forces that shaped everything you have followed: gravity pulling inward, energy pushing outward, motion redistributing matter across space. These forces do not allow infinite expansion. They allow temporary extension. As a star grows larger, its outer layers become more diffuse, more weakly bound. Gravity loses its grip at those distances, and the energy required to hold those layers in place becomes increasingly unstable. There is a point where extension becomes loss, where adding more size does not create a larger structure, but causes the structure to unravel. This is the true limit. Not a maximum radius that can be reached and held, but a threshold where cohesion begins to fail faster than it can be maintained. Beyond that threshold, a star cannot exist as a star in the way you understand it. Its outer layers drift away too quickly, its structure becomes too loose, and the balance that defines it breaks down. It cannot grow past that point. It can only dissolve. This is why the largest stars are not infinitely larger than smaller ones. There is a range, a region of possibility, where stars can expand to extreme scales, but that region is narrow, unstable, and short-lived. They approach the limit. They do not surpass it. And when they reach it, the process reverses. Material is lost, structure changes, and the star transitions into something else, something that no longer occupies that vast volume of space. The limit is not visible. It is enforced by the same physics that allows stars to exist at all. Gravity cannot be turned off. Energy cannot expand matter indefinitely without consequence. The system balances itself by preventing any one structure from extending beyond what it can sustain. Nothing is allowed to remain at the extreme. Everything returns. This applies beyond stars. Galaxies cannot grow without limit. Clusters cannot expand indefinitely without losing cohesion. Even the cosmic web is shaped by constraints, by the distribution of matter and energy, by the expansion of the universe itself. Every scale has a boundary. Not a wall, but a condition. And that condition defines what can exist, how long it can exist, and what it will become when it can no longer hold that form. The hypergiant is one expression of that boundary. A moment where matter has been pushed close to its structural limit, revealing how far extension can go before it gives way to transformation. From here, the original idea of the largest star changes one final time. It is not the biggest thing that exists. It is one of the largest things that can briefly exist without falling apart. And that distinction matters, because it means size is not just about how far something can grow. It is about how close it is to becoming something else. The larger it becomes, the closer it moves to that boundary. And once it reaches it, the system does not allow it to stay there. It moves on, which leaves one final realization waiting at the edge of this entire structure. Not about stars, not about galaxies, but about the way you tried to understand them in the first place. If the system does not allow anything to remain at the extreme, then the way you tried to understand it was never aligned with how it works. Because you were searching for an endpoint, a largest star, a final comparison, a place where scale would stop. But the system never provided one. Every time you moved outward, the frame changed. Earth dissolved into orbit, the star dissolved into environment, the environment dissolved into galaxy, the galaxy dissolved into structure. And each time, the comparison failed. Not because the objects were too different, but because the frame you were using could not survive the transition. You were not measuring things. You were replacing perspectives. The largest star ever discovered was never meant to be an answer. It was a fracture point, a place where your original model of size could no longer hold, forcing you to move into a different way of seeing. From object to system. From system to network. From network to motion. And now, from motion to something else entirely. Because the final layer is not about what exists. It is about how it is understood. You began with the assumption that size is something external, something you observe from a fixed position. But that position was never available to you. You were always inside the system, always moving with it, always part of the structure you were trying to measure. There was never an outside, only deeper layers inside. Which means the comparison you came here for was never possible in the way you imagined. Earth and the largest star cannot be placed side by side, not because one is too large, but because there is no stable frame where both can be held at once without changing the meaning of one or the other. The act of comparing breaks them. Or more precisely, it breaks your model of them. This is the final shift. The largest star is not something you can use to understand scale. It is something that forces you to abandon the idea that scale can be fixed at all. Because everything you have followed exists within a system that is continuously changing, continuously moving, continuously redistributing matter and energy across layers that replace one another as you look deeper. There is no final reference point. No stable ground. No permanent measure. Only temporary structures, appearing, expanding, dissolving, and reforming within a system that never stops. And within that system, the place you thought you occupied at the beginning, standing on Earth, looking outward, was never where you actually were. The place you thought you occupied was not wrong. It was incomplete. You were standing on Earth, looking outward, placing objects in the sky, assigning distance, assigning size, building a map where everything had a position relative to you. That map worked, but only within a narrow frame, one that depended on ignoring the deeper structure carrying everything at once. Now that structure is visible. And the map has changed. Earth is no longer a base. It is a moving surface embedded in layered motion. The largest star is no longer an object to compare against. It is a phase within a system that does not hold still long enough to be measured in the way you first imagined. The comparison did not fail because the star was too large. It failed because the frame was too small. You tried to hold both objects inside a single perspective, but each layer you uncovered replaced that perspective with a larger one, dissolving the previous map and revealing a new structure underneath it. This is how understanding changes. Not by adding more detail, but by replacing the frame entirely. The largest star forced that replacement. It stretched your sense of scale until it broke, until the idea of side-by-side measurement could no longer be maintained, until you were pushed into a different way of seeing, where objects are not isolated, where motion is shared, where size is temporary. You did not arrive at an answer. You moved into a different system of meaning. And within that system, the original question becomes something else entirely. Not how large the star is compared to Earth, but how comparison itself behaves when everything being compared is part of the same moving structure. Because once you are inside that structure, once you recognize that there is no fixed position, no stable frame, no permanent scale, the act of comparing becomes conditional. It depends on where you choose to stand. And where you stand is always changing. This is the quiet realization that remains after everything else has been replaced. You are not outside the system measuring it. You are inside it, moving with it, part of the same process that creates stars, expands them, dissolves them, and redistributes their material across the structures you now see. The largest star was never separate from you. It only appeared that way. And now that appearance has dissolved, leaving behind something more accurate and less comfortable. There is no stable distance between you and anything else. Only temporary relationships within a system that never stops rearranging itself. Which means the comparison you came for did not disappear. It transformed. From a measurement of size into a recognition of connection. Connection replaces comparison, but it does not simplify anything. It removes the illusion that things can be separated cleanly. At the beginning, Earth and the largest star felt like 2 points you could hold apart, one small, one vast, divided by distance. But now that distance has been revealed as something unstable, something that depends on the frame you choose. The separation between them becomes harder to define. They are not just far apart. They are part of the same process. The material that forms stars, planets, and everything in between does not belong to one structure permanently. It moves, transitions, recombines. The hypergiant sheds its outer layers, and those layers become part of the medium that will eventually form new stars, new systems, new configurations. Nothing stays assigned. Everything is reused. This is the deeper layer beneath scale. Because scale suggests hierarchy, larger and smaller, greater and lesser, but connection removes that hierarchy and replaces it with participation. Every structure, no matter its size, is involved in the same ongoing exchange. The star contributes. The galaxy carries. The web organizes. And within that chain, Earth is not separate. It exists because of the same processes, formed from material that once belonged to earlier stars, shaped by forces that operate across the same structures you have followed outward. You are not observing the system. You are a result of it. This is why the comparison feels incomplete now. Because comparing Earth to the largest star assumes independence, as if each exists on its own, as if their sizes define their meaning. But their meaning comes from how they participate in the system, how they form, evolve, and dissolve within it. Size does not define importance. Connection does. And connection does not stay fixed. It changes as matter moves, as structures form and break apart, as energy flows through different phases of the system. The hypergiant is connected to the clouds it came from, to the material it will release, to the stars that will form from that material in the future. Earth is connected to earlier generations of stars, to the system that formed the Sun, to the larger structure that continues to carry it through space. The connection is continuous, even as the forms change. This is the final replacement of the original idea. Not a larger object compared to a smaller one, but a network of transformations where size is only one temporary feature among many. And within that network, there is no fixed position from which to step outside and measure everything else. You are always inside the connection, always part of the exchange, always moving with the system that produces the very structures you are trying to understand. The largest star does not stand apart from that system. It reveals it. And once you see that, the question that brought you here does not disappear. It dissolves into something wider. Not how large something is, but how it belongs to everything else. Belonging replaces distance, but it introduces something more difficult to hold. Because if everything belongs to the same system, then nothing is truly separate enough to be understood in isolation. At the beginning, isolation made things simple. Earth here, star there, distance between them. A comparison you could imagine holding still. Now that separation is gone. What remains is relationship. And relationship changes constantly. The largest star is not fixed in space. It moves with its galaxy, shifts through regions of different density, interacts with surrounding material, loses mass into the environment that carries it forward. Earth does the same. Not in the same way, not at the same scale, but within the same structure. It moves through the galaxy, carried by gravitational flows, embedded in layers of motion that never pause long enough to become still. There is no isolated frame, only overlapping systems. And within those systems, understanding becomes something different. It is no longer about measuring one object against another. It is about tracing how one state leads into another, how one structure becomes part of a larger one, how every form you observe is connected to what came before and what will come after. The largest star is not just large. It is transitional. It shows you what happens when matter stretches toward its limit, when internal forces push outward as far as they can, when structure becomes so extended that it begins to dissolve back into the environment. Earth is not just small. It is stable. It shows you what happens when matter remains tightly bound, when forces are balanced in a way that allows structure to persist longer, to hold its form through extended periods of time. These are not opposites. They are different expressions of the same system. And that system does not prefer one over the other. It moves through both, continuously, shifting between stability and transformation, between compact forms and extended ones, between phases that last and phases that pass quickly. Nothing is fixed long enough to define the whole, only long enough to be part of it. This is the final layer of understanding that replaces the idea of comparison. You are not comparing objects across distance. You are recognizing positions within a process. Positions that change. Positions that dissolve. Positions that reappear in different forms as the system continues to move. The largest star was one of those positions. Earth is another. And both exist only because the system allows them to, for a time, before they become something else. There is no final scale, no ultimate size, no object that remains large enough, long enough to stand as a permanent reference. Only phases that pass through the system, each one revealing a different aspect of how reality is structured. And once that is seen, the question is no longer about size, but about where you are within the process right now. Where you are within the process feels stable, because your timescale is short. The ground beneath you holds its shape, the sky repeats its patterns. The motion that carries you is too smooth, too coordinated to be noticed directly. So the system appears still. But that stillness is not real. It is a compression of motion into something your perception can tolerate. The earth moves, The solar system moves, the galaxy moves, and all of it continues within a structure that is expanding and reshaping over time. You do not feel it, because everything near you agrees with it. This is the final illusion that allowed the original comparison to exist. The illusion of a fixed observer. You believed you could stand in one place and measure outward, comparing Earth to something larger, placing both inside a stable frame. But that frame depended on ignoring the motion that carries both of them together. Once that motion is acknowledged, the frame dissolves. There is no point where you can stand still long enough to measure everything else without that measurement being shaped by the movement you are part of. You are not outside the system observing it. You are inside it, moving with it, changing with it, carried along with the same processes that create stars, expand them, dissolve them, and redistribute their material across the structures you have followed. The largest star is not distant from you in the way you first imagine. It is separated by layers of motion and phase, not by fixed distance alone. And those layers are not static. They shift. Over time, the galaxy rotates, the star evolves, the material it releases spreads into the surrounding medium, and the system reorganizes itself again. The distance changes. The structure changes. The relationship changes. Nothing remains in the position you assigned to it at the beginning. This is the final reclassification of your perspective. You are not a stationary observer comparing objects across space. You are a moving point within a system of moving structures, where every comparison depends on a frame that is itself changing. The largest star was never meant to be understood as a fixed extreme. It was meant to show you what happens when your frame breaks. When the idea of stable size, stable position, stable comparison can no longer hold against the structure of reality as it actually behaves. And once that break occurs, you do not return to the original view. You cannot. Because now you see the motion. Now you see the connection. Now you see that every object, every structure, every scale you tried to hold in place was already part of something that never stopped moving, which leaves only one thing that remains consistent. Not size, not position, but change itself. Change is the only thing that does not disappear when every scale is replaced. Because it does not belong to any single layer. It passes through all of them. From the smallest structure you can stand on to the largest structure you can imagine, everything you have followed has been defined by change. Expansion, contraction, formation, dissolution, motion across distances that redefine what those distances mean. Nothing held its form. Not even for long. The largest star expanded until it could not remain what it was. The galaxy moved through structures that reshaped its environment. The cosmic web stretched as the universe itself continued to evolve. Every layer changed. And every change replaced the frame you were using to understand it. This is what remained consistent beneath everything else. Not size, not position, but the process of transformation itself. The star did not fail because it became too large. It revealed that size is not something that can remain fixed when the system is in motion. It showed you how matter behaves when pushed to its limits, how structure responds when balance begins to break, how even the most extreme forms cannot escape the conditions that created them. The largest star was never the point. The change it undergoes is. Because that change connects it to everything else you have seen. The material it releases becomes part of new systems. The forces that shaped it continue shaping other structures. The processes that drove its expansion and instability are part of the same system that formed Earth, that formed the Sun, that continues to carry you through space. You are inside that continuity, not separate from it. And once that is understood, the original comparison dissolves completely. Not because it was wrong, but because it was incomplete. You are comparing two states within a system that does not hold still long enough for that comparison to remain meaningful. Earth and the largest star are not endpoints on a scale. They are moments within a process. Moments that appear, hold briefly, and then change into something else as the system continues to move. There is no final size to reach. No ultimate object to compare against. No stable frame that can contain everything at once without being replaced. Only a sequence of transformations, each one revealing a different aspect of how reality is structured, each one dissolving the previous understanding and replacing it with something wider. And within that sequence, you never stopped moving. You never stood outside it. You were always part of the same process you were trying to measure, carried along by the same forces, embedded in the same structure, changing with it in ways that are too gradual to feel, but too constant to ignore once they are seen. The largest star did not show you how big something can be. It showed you that nothing remains that big for long. And that size itself is only a brief expression of a system that never stops becoming something else. The comparison you came for never arrives. Not because the star is too large, but because the frame that would hold that comparison does not exist. You began on Earth, looking outward, expecting to place two objects side by side, to measure one against the other, to understand scale as something stable and fixed. But every layer you passed through removed that stability. The planet became a moving surface. The star became an environment. The environment became a system. The system became a network. And the network never stopped changing. What you thought was a distance became a relationship. What you thought was size became a phase. The largest star did not give you an answer. It removed the question. Because there is no place where Earth and that star can exist together without changing what they are. There is no fixed position from which you can hold both in a single, stable frame and call that comparison complete. You are not outside the system measuring it. You are inside it, moving with it, part of the same structure that creates stars, expands them, dissolves them, and carries their remains into whatever comes next. The place you thought you occupied at the beginning was never still. And once you see that, the idea of something being larger than everything else becomes something quieter and more precise. Not the biggest thing that exists, but a brief expansion, passing through a system that never stops changing.